Hey. um, so now we're gonna learn. We learned about polynomial functions, and now we're gonna learn about rational functions. And rational is just a big word for like fraction. So basically, um, we're going to learn about when there's like a fraction, a polynomial at the top and a polynomial at the bottom, and like how to graph that. Not as bad as it sounds, I promise. All right, so there's two kinds of rational functions. The first is called the reciprocal function, just FYI. It has what's called asymptotes. An asymptote is a line that you can't touch. So the parent one, the main one, is right there at the x and y axis. Pretend that's like right there on the x and y axis. Oh my god, those are awful lines. Sorry. All right, and then looks like it's really close to it, but don't touch it. It's like that scene from Finding Nemo. They're like, don't touch the butt. Okay, well you can't touch the asymptote. You can get really close, but you can't touch the asymptote. All right, don't touch the asymptote. Oop, that should be curved. That should be curved. All right, so anyway, it looks like that. And then 1 over x squared goes up, up. All right, and no worries, if you can't remember it, go in your calculator, type 1 over x graph. It will look like this guy. If and 1 over x squared, it will look like that guy. All right, and so in those two, we have horizontal and vertical asymptotes. And so I'm going to call horizontal asymptote HA, so and I'm going to call vertical asymptote VA. And so horizontal is like this, vertical is like this. And so this is the vertical asymptote. And so vertical asymptote is when x equals a number, horizontal asymptote is when y equals a number. And so this number is x equals -3. And the horizontal asymptote is right here, and it's y equals -1. Notice that this relates to the domain, x equals, and this relates to the range. All right, so it's like a little thing. I have to have my blanket on because it's cold in here. I could put a sweater over my dress. All right. So here we want to find the domain and range of this graph. It's hard to tell, but there is an asymptote right here, so it's never crossing that line. So the horizontal asymptote goes like this, and the vertical asymptote goes like this. And so the vertical asymptote is when x equals a number, and so x equals -2. And the horizontal asymptote is when y equals a number, and that's 0. And so there's a couple of ways. That one's domain. That is range. And so there's a couple ways you can write it. So basically, since we have arrows, it's any number except that one. So you could say like all real numbers except x equals -2. Or you could write it like -infinity to -2 and -2 to infinity. Either way, range same way. You could say all real numbers, the double R, except, or you could write the word except, y equals 0. Or you could break it up and write it in interval notation, and you could say -infinity to 0 and 0 to infinity. So either way, however you want to write that, that's fine. Just remember, horizontal asymptote, range, because it's y, vertical asymptote, x, domain. All right, so to find the actual vertical asymptote when we're given a rational function, basically we're going to set the denominator equal to 0 and solve, is what all that says. Denominator equal to 0 and solve. All right, so here it doesn't matter what the top says if we're just finding the vertical asymptote. So we're going to set the denominator equal to 0 and solve. And so we get x equals 4. And so that's the vertical asymptote. And so the domain, if we were looking for the domain, that would be anything except x equals 4, basically. All right, let's do another one. Okay, here, we're going to take this x squared minus 5x minus 6 equals 0. Now to solve this, we can do completing a square, quadratic formula, graphing, square root, or factoring. Always a graph. Multiplies to give us negative 6, adds to give us negative 5. 6 and a 1, negative 5, so negative 6. So x minus 6, x plus 1. And so we're going to set each one of these equal to 0. And so we get x equals 6, x equals negative 1. All right, these are the vertical asymptotes. Okay, and if we wanted to find the domain, we could say all real numbers except x equals 6 and x equals negative 1 if they ask for the domain. But for the vertical asymptote, you set the denominator equal to 0 and solve. So I should write it down. Vertical asymptote, denominator equal to 0 and solve. Okay, again, vertical asymptote, denominator equal to 0. And solve. And so we can quadratic formula, completing the square, graphing, square root, or we can factor. So it's going to be negative 5 and 2. We get x minus 5, x 2. We're going to set each thing equal to 0. You see, so we get x equals 5, x equals negative 2. These are the vertical asymptotes. Okay, and so if they ask for the domain, then you would say, okay, it's all real numbers except x equals negative 2 and x equals 5. All right, let's do horizontal asymptotes. So there's some rules for horizontal asymptotes, and if I were you, I would do the same thing as I did with our other kind of complicated rules. I would just write it down. So what we're doing here for the rules is we're looking at the leading term, okay? And so we're looking at the exponents of the highest degree, and we're looking at the leading coefficient, okay? And so if the numerator, the degree of the numerator, is equal to the degree of the denominator, this one right here, then we're going to set the coefficients on top of each other and reduce the fraction. Okay, if the degree of the numerator is less than the degree of the denominator, they use n and m. I just used n and d because I can't ever remember. If it's less than, then you get y equals 0. It's just y equals 0. It's just the axis. If the degree of the numerator is greater than the degree of the denominator, it's right here, then there's none. All right, so this thing right here, you just write it down like to the side where you wrote down kind of like your multiplicity rule and your end behavior rule, and just have it like for easy access. So let's look at horizontal asymptote. Okay, so here we are. The degree of the numerator is 3. The degree of the denominator is 6. So we have 3 and 6, and it's less than. And so when the degree of the numerator is less than the degree of the denominator, it's y equals 0. So I just looked at my little list. And so if we wanted to find the range, by the way, we would say all real numbers except y equals 0. Answer no. Right here, it's hard to read, but that says x3 minus 5 over x squared. So the degree of the numerator is 3. The degree of the denominator is 2. And so we have 3 and 2, and 3 is greater than 2. I always write the numerator first, and then I write the denominator. And then I figure out what sign goes here. And then after I figure out what sign goes in the middle, I look at my little rule. So when the numerator is greater than the denominator, there is none. No horizontal asymptote. And so that means that the range would be all real numbers. There's no asymptotes to get in their way. Right here, this guy, we need to write him in descending order. That's 3. All right, so the degree of the numerator is 3. The degree of the denominator is 5. So numerator first, then denominator. I'm looking at degree, Kelly. Not exponent. Okay, so they're equal. And when they're equal, you take the coefficient of the numerator, so -2, and put it over the coefficient of the denominator, so 5. So our asymptote would be y equals -2/5. So that means our range would be all real numbers except y equals -2/5. And I got the -2/5 from the coefficient of the term with the highest exponent. Okay, and so I'm going to stop the video, and in the next video, we're going to do graphs of basic rational functions.